Let's try a modeling question. So it says, in an orienteering exercise, a cadet leaves the starting point O and walks 15 kilometers on a bearing of 120 to reach A. So let's draw O. This is north, 120 degrees, I'm going to say something like that. And it goes 15 kilometers. 120 degrees, 15 kilometers, reaches A. Cool. A is the first checkpoint. From A, he walks 9 kilometers on a bearing of 240 degrees to the second checkpoint B. So again, we draw north, 240, I'm going to say something like that. Draw the line, gets to B, that's 9 kilometers. From B, he returns directly to O. So something like that. Okay, cool. Find the position vector of A relative to O. Okay, here's what we're going to do. We're going to take O to A, right? O to A, 15 kilometers. Now, if this whole thing is 120, I can split that into a horizontal part and a vertical part. This is therefore 90 degrees and this is 30 degrees. Now what I'm going to do is I'm going to resolve horizontally and resolve vertically. There are two components, horizontal, vertical component, to this vector O to A. Okay? To express the horizontal component, so this line here, I'm going to do 15 and then cos 30 degrees. And I'm using cos because I'm adjacent to my angle. I've got the hypotenuse, 15. I've got the angle, 30. If I want to express the adjacent, I do hypotenuse times cos angle. Okay? If I want to do the vertical component, which is this blue part, I'm going to do 15 sine 30 degrees. Because sine is opposite over hypotenuse. So to work out the opposite, I do hypotenuse times sine angle. So 15 times sine 30. So to get from O to A, my position vector will be 15 cos 30i minus 15 sine 30j, because I'm going downwards. So now it's just a matter of plugging that in the calculator and you get 13i minus 7.5j kilometers. Okay. That's part A done. Part B. Part B is asking for the magnitude of OB. But first, we need to work out OB. Now, let's draw it again. Something like this. We've got north and north. This is the right angle triangle which we drew before. We said that this is 90. We said that this is 30. This angle, we don't know. Okay. This we know is 240 degrees. Okay. do we know what this angle is here? This shaded one. What would that be? 60. Because if you have a look at this diagram, do you remember the F stuff in GCSEs? If this is 120, then this angle plus the 120 has to add up to 180, which makes that 60 degrees. So that means that is 60 degrees. So what is this angle? Let me do it in blue. What is that blue angle going to be? 60. Because it all has to add up to 360. Cool. And we know that this is 15. We know that this is 9. So to work out x here, what can we use? Cosine rule. So OB squared is equal to 15 squared plus 9 squared minus 2 times 15 times 9 times cos 60 degrees. This gives us 171, and then we do the square root of 171, which is our magnitude of OB, so 13.1 kilometers. Okay. C, the bearing of B from O. Okay. So in part C, we're trying to work out the bearing of B from O. So that's B. Yep, so we need to work out this angle here in order to add it to that 120. That will then give us the angle of B from O. So how can you work out that missing angle? What can you use? Sine rule. Sine theta over 9 equals sine 60 over root 171. I'm not going to use 13.1. If I use 13.1, then I'm going to be a few decimal places off. You don't want to round at the start, you want to round at the end. So that means sine theta is equal to sine 60 over root 171 times 9. And then to work out theta, we're going to do the sine minus 1 of all this, which gives us which gives us 36.6 degrees, so 37. That's this yellow bit here. To get the bearing, we have to add 120. So 157 degrees. Okay. Part D. The position vector of B relative to O. Okay. Let's draw a right angle triangle. O. Let's make that B. This angle will be what? That's going to be 67 degrees because it's relative to north. We know the whole thing is 157 and we've been given the right angle, or we know that that's a right angle. This is 13.1 kilometers. So again, can you resolve vertically? Can you resolve horizontally? Can you find out what this is and what this is using the whole sine and cos thing we did earlier. So the horizontal will be 13.1 cos 67 because we're adjacent, 13.1 sine 67 because we're opposite to the angle. Okay, so that means OB is 13.1 cos 67 degrees I minus 13.1 sine 67 degrees J. So 5.1 I minus 12.1 J. That is a modeling question. It is hard. Modeling is always the hardest part, but just do enough practice. Try as many questions as you possibly can.